Hello and welcome back, Math 140 students. I'm your instructor, Cindy Enrique, and we will continue with Chapter 7. So Section 7.1 is all about the rational expressions and rational equations. So we define a rational expression to be a ratio of two polynomials, or better yet, it's just a fancy way of saying it's a fraction of polynomials, okay? The most important thing that we need to know about a rational function is that the denominator cannot be equal to 0, okay? That is going to be huge here. So our denominator is not equal to 0. So remember, when the denominator is equal to 0, it gives us something, and we say that it's going to be undefined. Okay, so for example, if I were to have the fraction 5 over 0, that is undefined, or it says error on your calculator. Okay, so finding the domain is making sure that you find the problem points. So what you want to do is find where your problem point is, and that's going to be the point where something bad happens, so you take it away. So we set the denominator equal to 0 and we solve for it, and the domain is all the real numbers except for that problem. So for example, number 1, we have 2 over x minus 3. So I'm going to look at that denominator, which is my x minus my 3, set it equal to 0. When I add 3 to both sides, I will get that x is equal to positive 3. So positive 3 is my problem. That is my restriction. So I know if I were to draw this out for my visual people on the number line, if I have number 3, so it's all the numbers except for positive 3. So my set builder notation. So I am now doing my set builder notation. So that is going to be the parentheses, or sorry, the curly braces. It's the variable x such that x does not equal to 3. And then you close your braces. For part number B, it says write it in interval notation. So then my interval notation would go from negative infinity to positive 3, comma, union 3 to positive infinity. This tells me that it's all the real numbers except for the number 3. Okay, so for part number 2, it's the same process. So we want to find the domain, and we want to write it in set builder notation and interval notation. So again, we want to find the problem. The problem is going to come from the denominator. So I'm going to set my denominator, x plus 6. Now I'm going to set that equal to 0. So when I subtract it to the other side, let me write that a little bit better. So x is equal to a negative 6. I subtracted 6 from both sides. So for part A, I'm going to have my set builder notation. So set builder notation, I have the variable x such that x cannot equal negative 6. Okay, and then you close that set builder notation. For part B, I wanted in my interval notation. So interval notation, again, visually, if you want to see it, it's all of the numbers except at negative 6. So I'm going to go from negative infinity to negative 6, union negative 6 to positive infinity. Okay, and so that's going to be my answer. For number 3, we have a degree 2 polynomial, and it's still doable. Whenever it's degree 2, that's the exponent. There's a couple of things we can do. We can either factor, if you can. Or you can use the quadratic formula. Actually, the only thing that we do know how to do is factor. So let's try factoring. So if I were to try to factor this, I would have 2x and x. I would have 1. So let's see. So of course you can do the AC method, where you have your A and your B, and then you kind of put it all together and change it into 4 terms. Or you can do guess and check. For this, I'm doing guess and check. So this is going to be a negative, and that's going to be a positive. That would give me a positive 2x squared, negative 2x, and a positive x. That gives you a negative x. And positive 1 times negative 1 is a negative 1. So therefore, that is how I factor. Or like I said, if you like the AC method, do the AC method. So now I set each parentheses equal to 0. So I'm going to have my 2x plus 1 is equal to 0. So then 2x is equal to a negative 1. So x is equal to a negative 1/2. And my other one, x minus 1 is equal to 0. So x is equal to positive 1. So if I was just looking at this visually, I know that these points are bad points. So negative 1/2 and a positive 1 are my problem points. So I'm going to have open circles there. And everything else is fair. So if I were to write this in my set builder notation, I would say x such that x cannot equal a negative 1/2 or 1. That is my set builder notation. For my interval notation, it's from negative infinity to negative 1/2. Union negative 1/2 to 1. Union 1 to positive infinity. So that is going to be my final answer. Okay. Notice how I have 3 different parts here. Okay. And if you guys have any questions, please email me. Now, for the second part of section 7.1, we are going to be simplifying rational expressions. So in order to simplify these rational expressions, we are going to factor both the numerator and the denominator if possible, cancel out the common factors, and simplify the expression. So what I like to do is I kind of like to split it out. So I have my numbers that are being multiplied, so I can think of that being one thing. And then I like to kind of color code it. So this is my a to the 5th, and down below I have my a to the 8th. And I also like to give myself plenty of room. And I have my b to the 3rd, and my b, when there's no exponent, you can always default it to be a 1. So now it's going to become a little bit easier to deal with each one individually. So I have 9 and 18. Well, I know that 9 divided by 9 is 1, and 18 divided by 9 is 2. So up on top, I'm going to have a 1, and down at the bottom, I'm going to have a 2. So I have a 1/2. Now, if I'm thinking about my a's, well, I think about which one is bigger. The one on the bottom is 8, the one on the top is 5. So I know it's going to live on the bottom because that's where it's bigger. So if I have 8 and 5, I do a subtraction. 8 minus 5 is going to give me 3. So now I dealt with my a's. Now the next thing I want to work with is my b's. So now I want to see, okay, which one has a bigger exponent, the numerator or the denominator? Well, you've guessed it, the numerator is bigger, so I know that my b is going to live in the numerator. So just like I did before, I'm going to do a subtraction. So 3 minus 1 gives me 2. So now I know exactly how this is going to, reduce. So I can rewrite it as b squared 2a to the 3rd. I could keep that 1 or not keep the 1. It's your choice. I wrote it down the first time in red so I can see my work. But when I write my final answer, I decided not to have it or you can decide to have it. It doesn't change the value at all. Okay. Now for number 2, for number 2, it looks like I have addition and subtraction. So whenever I have the addition and subtraction, that's telling me to factor. Notice how in number 1, everything is being multiplied. So everything in number 1 is being multiplied. And in number 2, I have addition and subtraction. So that tells me that I want to factor. So this is where I follow the instructions. So I'm going to factor both the numerator and denominator if possible. So okay, here I go. So I'm going to factor the numerator first. Hopefully you guys are getting faster at factoring, because hopefully you guys are getting more comfortable with it. So if you need to do the AC method, go ahead and do the AC method. I know that I can factor by the guess and check. So that's what I'm going to use, guess and check. So up in the numerator, I have x times x gives me x squared. So that's fine. Now to give me 28, there's a couple of factors that can work, but I definitely wanted to add it to number 3. So I think I'm going to do, oops, sorry there guys. I believe 4 times 7 is 28. So I'm going to go ahead and write that down. So I have 7, and then I have 4. Okay, and since I want the addition, the middle, to be positive 3, I'm going to have a positive 7 and a negative 4. So that is how I factored my numerator. And down below, I want to factor my denominator. So my denominator, I have 2 terms. So I'm going to have a GCF. That GCF is 2. That's a 2. Sorry guys, my pen is running out on me here. Let's try that again. It's a 2. And so I have x plus 7. So now I factored both the numerator and the denominator. Now I want to cancel out common factors. So this is an x plus 7, that can be canceled. And that's an x plus 7, so that can be canceled. So now I just simplify the expression. So my final answer here, I'm going to have my x minus my 4 over 2. And so that's going to be my final answer. Okay. Now for number 3, it's the same process. I am going to factor both the numerator and my denominator. This is an exponent of 3. So I have a degree 3. So when it's degree 3, I know that I'm going to be looking at the difference of cubes. So hopefully you guys have that formula handy. It was in chapter 6. So if you need to look at your chapter 6 notes, go ahead and grab your chapter 6 notes. So I'm going to have p minus 3 p squared plus 3p plus 9. That is how I factor my numerator. Now I want to factor my denominator. So when I factor my denominator, I know that I'm going to have 2 parentheses. P times p is p squared. To give me 9 is going to be 3 times 3. Now if I want the middle to be negative 6, then it would be negative 3 and negative 3. And negative 3 and negative 3 is negative 6. Negative 3 times negative 3. A negative times a negative is a positive. And so I know that I have to cancel out common terms. So this p minus 3 can cancel out with one of those p minus 3. So my final answer, I'm going to have my p squared plus 3p plus 9 all over my p minus 3. Okay, and so that's going to be my final answer. Now for number 4, we do the exact same thing. We're just getting comfortable with factoring. So here what I'd like to do to begin with is actually rewrite it so that it's in descending order. So I'm going to make sure that I rewrite it this. So negative 5x plus 20 up on top, and down at the bottom I know that I'm going to have my x squared minus x minus 12. So up on top I'm going to have a GCF. That GCF is going to be 5, and since that leading coefficient is negative, it's going to be a negative 5 that I'm going to factor out. So I'm going to have this as a negative 5 x minus 4, because negative 5 times negative 4 is positive 20. And down at the bottom, when I factor this, two numbers that multiply to 12 is 3 and 4. And if I have a negative 4 and a positive 3, it adds up to give me negative 1. And I have positive 3 times negative 4, which is a negative 12. And do I have any factors that are going to cancel? I do. The x minus 4 and the x minus 4 cancels out. So my final answer is a negative 5 up on top. And down at the bottom, I have my x plus 3. Okay. And so that's my final answer. So you always factor, cancel like terms, and then simplify your final answer. So now in the next section, we're going to have some practice problems. So we have practice problems all the way to the end, well, I guess to the top of page 5. So these are all our practice problems. So the first set of practice problems is figuring out the domain. Remember, for the domain, what we want to make sure is that our denominator equals to 0. That is how we figure out the domain. Okay. So we want to make sure that we set the denominator equal to 0. And then write the answer in set builder notation and interval notation. So this is where I'm going to press pause, and you guys are going to work on these, and then I'll show you the answer. So please press pause now. Okay, so you guys hopefully have pressed unpause. So the practice problems, remember the domain, we want to set the denominator equal to 0. So for problem number 1, I just have an x in the denominator. So the only number that's going to make that undefined is if that number were 0. So x equal to 0 is undefined. So that's the only bad point. So we have our set builder notation and our interval notation. For problem number 2, again, we set the denominator equal to 0. When we do that, we get 5 over 2. So I have my set builder notation and my interval notation. For problem number 3, again, I set the denominator equal to 0. Here, it's a difference of squares, so that's the conjugate pairs. That's going to be my, oh, actually, I made a small mistake here now, didn't I? So this is good that we are checking this. What is the square root of 4? The square root of 4 should be 2. So this is perfect in checking my work. And because now I know that I have a couple of things that are wrong. The square root of 4 is 2. So it should be t plus 2, t minus 2. So t plus 2 is equal to 0. So t cannot equal to negative 2. t minus 2 equal to 0, so t cannot equal to a positive 2. So for my set builder notation, t cannot equal plus or minus 2. So for my interval notation, it goes from negative infinity to negative 2, negative 2 to positive 2, and 2 to positive infinity. So that was perfect because I went too fast and furious. I needed to see that it was the difference of squares, and so the square root of 4 is 2. All right, so for number 4, it's the denominator is just equal to 8. So 8 equal to 0 doesn't make any sense, so there is no restriction. So there is no restriction. So you say x is all the real numbers, and all the real numbers go from negative infinity to positive infinity. For number 5, we're still looking at the domain. We're still looking at the restriction. So from here, looking at the graph, you want to see where the problem is. Notice how the problem is when x is equal to 2 and when x is equal to 0. That blue line cannot cross the x is equal to 2 and the x is equal to 0. So since that is the case, we say that x cannot equal 0 and x cannot equal to 2. So our interval notation goes ahead and identifies that. For practice problem number 2, when we're simplifying, that's all we're doing. We're just simplifying. So for number 1, that's our rules of exponents. You know how to do that. If you need to color code it, go ahead and do so. For number 2, I just went ahead and wrote it all out so that way you guys can see it. So if it's r minus 3 to the 5th power, that means that there's 5 of them. If I have r minus 3 squared, that means there's 2 of them. If I have r to the 3rd power, that's r times r times r. So I went ahead and just wrote it all out so that you can see it. Or you could have just seen that like, hey, if I have a 5 and a 2, well, 5 is bigger and 5 minus 2 is 3. So notice how I have 3 of those r minus 3. And out in front, the r divided by the r to the 3rd power, well, 3 is bigger, so then 3 minus 1 gives me my 2. And of course, you can look at the visual if you need that. For number 3, I went ahead and factored the numerator and the denominator. The y minus 1 canceled, so I'm left with y plus 9 and y minus 4 on the bottom. For number 4, what I did is I factored by the greatest common factor. The numerator has a GCF of 5. The denominator had a GCF of 3. Therefore, the y minus 3 on top and bottom both cancel, so I'm left with 5 over 3. For number 5, what I did for the denominator is I rewrote it in descending order. So I rewrote it as negative 4 plus 14. And then what I did from there is I factored out a negative. And when I factored out that negative, that y now turned positive and that 14 turned out to be negative. So it ends up canceling it out, so I'm left with a negative 1. For number 6, what I did is that numerator, it was a difference of squares. So I have 2w plus 7z and 2w minus 7z. Down at the bottom, I factored out a GCF of 2. And then what I did from there is I wrote it in alphabetical order. I wanted my w to come before my z, so I did that. And once I rewrote it in alphabetical order, I noticed how that leading term is negative, so then I factored out a negative 1. When I factored out a negative 1, that 2 now became negative 2, and I saw that that 2w minus 7z could cancel out. So my final answer is 2w plus 7z over negative 2. For number 7, I have a 4-term polynomial, so I factored by grouping. Notice how I do it separately. I did my numerator over to one side and I did my denominator over to another side. This way it just makes it a lot easier for myself. So the numerator actually ended up becoming 3 terms, as well as the denominator ended up becoming 3 terms. So I put them all together, the numerator over the denominator, and I saw what canceled. So what was left over was x minus 5 over x plus 2. For number 8, I saw a degree 3, so I automatically thought of my cubes. This is a subtraction, so it is a difference of cubes. So that's how I factored out the numerator. The denominator, I went ahead and factored. And then I canceled out the w minus 3, and that is what is left over. And that is the end of section 7.1. If you guys have any questions, please feel free to email me. And of course, your homework, you'll have plenty of time to practice. All right, well, see you guys next lecture.